This by internet remote controlled robot is about 28 cm long, 24 cm wide and 15 cm high. The materials it is made of were lying around in my storerooms and only a few tools were used to create it. So it should be no problem to do the reverse engineering or the mechanics. The host computer is a tiny notebook with a X-Core 86 CPU. It is an EduBook of the Nortec company running the Linux distribution Knoppix in version 6.2. The rover is driven by a geared electric motor with a total transmission of 1 to 90. Turning left or right is done by a standard servo. The connection to the host computer is implemented by a microcontroller of the Atmel company running the firmware vUSB of Objective Development. The webcam is fixed on a turnable lever, so it can be lifted for about 20 cm. The lever is actuated by a winch, which is turned by a second servo. The third servo is used to adjust the vertical view angle of the camera. 38 white LEDs, which can be dimmed by pulse width modulation, are used as headlight. The voltage supply is done by cabling, running from a computer power supply to the ceiling beam and finally to a 35 cm high power pole at the top of the rover. The cables are tightened with the help of a deflection roller fixed at the ceiling beam and a counterweight. To avoid the rover from getting tangled up in its own cabling, the cords are running to the power pole at the top of the vehicle, equipped with an anti-twist mechanism. 3 cables are providing 5 and 12 volts. The 12-volt line is running to the tiny laptop and the control electronics needs the 5-volt supply. At the front of the rover there is an infrared interface using 3 infrared diodes and 1 receiver module. The interface is used to communicate with other microcontrollers. Here you can see a turntable being controlled via the interface. While the rover doesn't move, the current running through the mesh cable is below 1 ampere. The EduBook, the VLAN stick and the radiator are consuming less than 12 watts in sum. While driving, the current is increasing to a value slightly above 1 ampere. A current between 100 and 200 mA is running through the electric motor. With a voltage supply of 5 volts, we get an electric power consumption between 0.5 and 1 watt. While driving the rover with the headlight turned on, the current is rising for approximately 100 mA according to a power consumption of 1.2 watts at 12 volt input voltage. If the rover hits an obstacle, we get a current of 1.4 ampere. The current running through the locked motor is below 500 mA, which is why there is no mechanism or electronic used to turn off the motor while being locked. Even with the drive motor, the light and all servos turned on, the current doesn't exceed a value of 1.6 ampere. Yet it is impossible to drive through the RoboSpatium with a full high-definition video stream because of the low data rate of my intranet connection. The robot is controlled by a browser with JavaScript enabled and the full resolution of the camera is used just for single snapshots. Driving the robot is more like steering a rover at the surface of the moon. The control software and the wiring scheme is available as download at the project page. At these pages you can drive the robot through the RoboSpatium, meaning the robot space. Just try it.